Hi there grade 9s and welcome back to the next exciting lesson in WorksheetCloud Maths. I hope you find it as exciting as I do. Maths. Okay, we're going to carry on today with functions and relations, and it's going to be our last lesson in this section. And we're going to just look at some exciting things when we compare graphs on one Cartesian plane and how they have relationship or don't have relationship to one another. So let's have a look at the first one. There's our Cartesian plane. Remember we went over that in the last lesson with the horizontal axis being the x-axis and the vertical axis being the y-axis. Right, let's have a look. If we say that y is equal to 4, we can pull together a whole lot of different ordered pairs where y is always 4. So let's have a look. We've done that here. Where x is minus 2 and y is 4, x is minus 1 and y is 4, x is 0 and y is 4, x is 1 and y is 4, and x is 2 and y is 4. Now we're only going to plot one of the points that stands out, and that will be where it intercepts the y-axis. Okay, so that will be, it'll intercept the y-axis at 4 because that is where x will be 0, as you can see there. Now, if we had to plot the others, we would say minus 2, y would be x would be minus 2, which is here, and y would be 4. So it would be that point. Then x would be minus 1, which would be there, and y would be 4. Can you see what's going to happen? We are going to create a straight line because the next ordered pair is where x is 1 and y is 4, and then x is 2 and y is 4. So each time we are creating a pair on a straight line where y is equal to 4. So it will be parallel to the x-axis because in each case y is 4. Okay, now what happens if we have, that will create, a horizontal line, as I said just now. Okay, what happens when we have x is equal to 4, right? So we're going to then plot where y is 0 and x is equal to 4, and then we'll plot up and down from there. So let's just have a look. We've got our ordered pairs. Every single time x is equal to 4, y can change. Okay, so where y is minus 2 and x is 4, there, y is minus 1 and x is 4, y is 0 and x is 4, y is 1 and x is 4, and y is 2 and x is 4. And let's see what happens. There we've plotted the one where where y will be 0 and x will be 4, and we join the other dots. Okay, I could have plotted all of them along here, but as you can see, it ends up being a straight line, and you are right, it is a vertical line. So when x is equal to 4, that is actually the x-intercept. When y is equal to 4, that is the y-intercept, and we are given no other values. So those two will be straight lines. But as you can see here, they cross here where x and y are both equal to 4, and that forms perpendicular lines. All right, so we're going to have a look later on at how we can tell where lines will be perpendicular. All right, so there we have it. Those two lines, we've given no other information other than y is equal to 4. So x can have any value as long as y is equal to 4, and it creates a straight horizontal line. Okay, where x is equal to 4, y can have any value, but because x is equal to 4, it creates a vertical line, and it is parallel to the y-axis. All right, everybody happy with that? And when those two cross, they become perpendicular lines. Right, let's have a look at something else. What about the graph where y is equal to x? So every time we've put in ordered pairs, y and x have to be the same value. So we've got minus 2 and 2, we've got minus 1 and 1, we've got 0 and 0, we've got 1 and 1, and we've got 2 and 2. Okay, so again, we've seen that they have to be the same. Y is where x is minus 2, y is minus 2. Where x is minus 1, y is minus 1. And this graph will go through the point of origin because where x is 0, y will be 0. And the same with 1 and 1 and 2 and 2. Okay, so we then draw a line through that. Okay, so here it is your gradient will be 1. Okay, there is no y-intercept put in here, but it would be naught because it's been left out. So that is equal to y is equal to x plus naught. When there's nothing in front of the x, the gradient is 1. The y-intercept will be naught. Okay, as you can see there, it's gone through the point of origin on your Cartesian plane. You've got some in the third quadrant and some in the first quadrant. Okay, remember this is the first quadrant where both are positive, both points are positive, and some in the third quadrant where both points are negative. Remember, first quadrant, second quadrant, third quadrant, fourth quadrant. Okay, let's move on. What about when the graph is y is equal to minus x? Because now the only thing that has changed is our gradient. Remember, that minus shows that our gradient is minus 1. But our y-intercept is still naught because it doesn't say plus anything here. So we presume it's plus naught. Well, it has to be plus naught. That's why we don't write it. It doesn't have a value. Okay, so if our ordered pairs are like this, if x is minus 4, you put in minus 4 to where x is, it's going to give you a positive 4, which is going to give you y. Okay, let's see where that point is plotted. Can you see x is minus 4 and y is 4? Can you think what's going to happen here? Let's carry on and see. Minus 3 and 3, minus 2 and 2, minus 1 and 1, naught and naught. So it's going through the point of origin because our y-intercept is naught. Okay, and then 1 and minus 1. Right, there it crosses, and it crosses at the point of origin. Right, our gradients are exactly the opposite. The one is positive 1. There we go, there's our positive graph, and the other one is negative 1, and there is our negative graph. Okay, negative gradient. And those two happen to be perpendicular. Have a look at where they meet. There's a 90-degree angle there. How can we say this? First of all, because the point of origin is the same, or rather the y-intercept is the same, which is the point of origin. Okay, and also the gradient is exactly the same, it's just opposite. In other words, the one is plus 1 and the other one is a minus 1. Okay, everybody happy with that? So just by looking at the formula, you can tell a lot about two graphs. Here you can see is both of the y-intercepts have been left out, so they would be naught. And the one gradient is positive and the other one is negative. So there they cross, and where they cross, there would be a 90-degree angle, which means the one line is perpendicular to the other one. Right, let's look at another one. If we had to draw the linear graph of y is equal to 2x, there's our ordered pairs. Okay, for every x value, we are going to multiply it by 2. Minus 3 times 2 will give me minus 6. So that's our first ordered pair. Let's see where that happens. Okay, there we go. Where x is minus 3, y is minus 6. Okay, when we put in minus 2 into here, where x is minus 2, y will be minus 4. Let's put that one in. Where x is minus 1, y will be minus 2. Where x is naught, y will be naught because 2 times naught is naught. Where x is 1, y is 2. Where x is 2, y is 4. Where x is 3, y is 6. Okay, everybody happy with that? Right, let's join the dots, and there you can see we have a graph. Okay, the next one, what happens if you've got y is equal to half x? The point of origin is still 0. Okay, there's nothing added on here, so it is 0. But our gradient is not the same, and it's also not opposite. So let's put in these ordered pairs. So where x is minus 4, half of minus 4 will be minus 2. There we go. Where x is minus 2, y is minus 1. Where x is naught, y is naught. So it also crosses the point of origin. Where x is 2, y is 1. And where x is 4, y is 2. And we join those points. Okay, they are totally unrelated, those two graphs. Okay, they have the same point of origin, but they have a completely different gradient. Right, let's look at the next one. Draw the linear graph for y is equal to 2x. Okay, there we go. We've just drawn that graph. Okay, and now where y is equal to 2x plus 2. Now can you see here, the gradient is exactly the same, but the point of intercept, the y-intercept, is different. In the second graph, we've actually got y is equal, or rather the intercept is plus 2. In the first graph, the intercept was 0, the y-intercept was 0. So this should tell us something. The gradient is the same, but it's crossing the y-axis at a different point. Let's see what happens. Okay, there are our ordered pairs. We've got minus 4 and 6, because, and minus 6, because if you put in minus 4 for x, minus 4 times 2 is going to give us minus 8, plus 2 is going to give me minus 6. The same with minus 2 times 2, it's going to give me minus 4, plus 2 is minus 2, 0 times 2 is 0, plus 2 is 2, 2 times 2 is 4, plus 2 is 6. So let's plot these coordinates, these ordered pairs, and see what it looks like. All right, there's the first one, there's the second one, the third one, and the fourth one. And we can draw a line straight through. What do you see? Yes, they are parallel lines. Let's have a look at this one. Y is equal to 2x plus 6. Okay, it's got a different y-intercept, but the gradient is the same. Can you see for each one the gradient is 2? Okay, so I'm sure you can imagine there are ordered pairs. We're going to just presume that this is going to be parallel to these other two lines, but let's just work it out, okay, and draw it, and then we can compare. Right, so where x is minus 4, y is now minus 2. Where x is minus 2, y is 2. Where x is 0, y will be 6. And where x is 2, y is 10. Let's plot those. Okay, there we've got minus 4, minus 2. We've got minus 2 and 2. Here we've got 0 and 6. See, that's where the y-intercept is. As you can see, that's the y-intercept. And then 2 and 10. Right, we join those dots. Can you see? They are parallel lines. Okay, the lines are parallel. So in order for them to be parallel, your gradient has got to be the same, which makes sense, but your y-intercept can then be different. Okay, so you need to look at the gradient. If the gradient is the same, it means that the lines will be parallel. Remember, a negative gradient will cause it to go up in an opposite direction, and therefore the lines will not be parallel. They could be perpendicular, but they would only be perpendicular if they were crossing the y-axis at the same point as what we saw just now. Right, let's go on. Okay, now what I want you to do is I want you to see whether the following graphs, and they're going to be given to you in a formula format, are parallel, perpendicular, or unrelated with what we've learned so far in this lesson. Look for gradients, look for y-intercepts. Okay, those will give you the clues. But each time, to prove it to yourself that your reasoning is right, you need to draw a graph. So you need to decide whether the following are parallel, perpendicular, or unrelated. Then you need to give a reason, and then you need to draw the graph to prove your reason. So there is the first one, second one, third, fourth, and fifth. So you've got 5 to do. What I want you to do is pause the video, and I want you to try and work all those out. It might take you a while because you need to draw the Cartesian plane. Please remember, if you are getting stuck, go back in the video and watch the first little bit of it, and you will actually be able to work it out for yourself. But a big hint is to look for the gradients and to look for the y-intercepts, and then you can see how they go together, or whether they are related or whether they aren't, and if they are related, how are they related. Okay, right, we will come back just now once you've done all of that. Okay, let's go on and see how you did. Right, there's our first one. Y is equal to 3x minus 2. Y is equal to 3x minus 5. Okay, have a look there. You should have said that these two were parallel because the gradient is the same, but the y-intercept is different. So what we would need to do is, as you can see, they're parallel graphs, same gradient, different y-intercept. This is exactly what I said just now. Okay, so we've got our Cartesian plane there. what you need to do is actually draw up a graph, not a graph, a table, to get some ordered pairs for the one and for the other one. So each time I'm going to use a different color so that you can actually see and you can relate the one graph to the other graph. So the first one is going to be blue. So we've got 1, 2, 3, 4 for our x values. We substitute into our formula, and then we will find out what our y value is. So if we substitute 1 into this formula, 1 times 3 is 3, minus 2 gives me 1. 2 times 3 is 6, minus 2 is 4. 3 times 3 is 9, minus 2 is 7. And 4 times 3 is 12, minus 2 is 10. Right, let's plot this graph before we do anything else. Okay, there we go. 1 and 1, 2 and 4, 3 and 7, 4 and 10. Join them up, and you can see it will go through the y-intercept minus 2. So draw your graph so that it goes through the y-intercept. You can then check that your points are correct, but if your y-intercept is correct. Okay, let's have a look at the next formula, which is y is equal to 3x minus 5. This time, remember, gradients are the same. So that should tell you that they are parallel lines. Okay, so we've got x is 1, where x is 1, 1 times 3 is 3, minus 5 gives me minus 2. Where x is 2, that's 6 minus 5, which will give me 1. Where x is 3 will be 9 minus 4 will give me, 9 minus 5 will give me 4. And where x is 4, that will be 12 minus 5, which will give me 7. Right, let's plot those points. There we go. That's 1 minus 2, 2 and 1, 3 and 4, and 4 and 7. Okay, join those lines. Make sure it goes through the right y-intercept, which is 5 there. Okay, and we can tell that they are parallel lines. They have the same gradient, but they cut the y-axis at a different point. Okay, let's go on. Right, here's the next one. Y is equal to a half x plus 1. Y is equal to 3x plus 1. Okay, now this we need to see. I would say that they're unrelated because they've got different gradients, but they've got the same y-intercept. Okay, now let's just have a look with our points. All right, so now we've got where x is 1, 1 times a half is a half, plus 1 is 1 and a half. Right, where x is 2, 2 times a half is 1, plus 1 gives me 2. Where x is 3, 3 times a half is 1 and a half, plus 1 gives me 2 and a half. Where x is 4, half of 4 is 2, plus 1 gives me 3. Let's plot this graph. There's 1, 1 and a half. There's 2 and 2, 3, 2 and a half, and 4 and 3. Okay? See where the y-intercept is? It is at 1. Okay, so when I draw my line graph, it will go through my y-intercept and it will go through all the points. So where x is 1, y is 1 and a half. Where x is 2, y is 2. X is 3, y is 2 and a half. And x is 4, y is 3. Okay, let's look at the next one. We've taken the same x values, 1, 2, 3, and 4. It's just easier to work with those ones. You could have worked with any ones. It really wouldn't have mattered. The graph would have looked the same. Your points would have just probably been more spread out if you had looked at, say, 1, 3, 5, and 7, for example. Okay. All right. We're now going to plug these ones, 1, 2, 3, 4, into this formula and see what we come up with. All right. We've got 1 times 3 is 3, plus 1 is 4. 2 times 3 is 6, plus 1 is 7. 3 times 3 is 9, plus 1 is 10. 4 times 3 is 12, plus 1 is 13. Well, you can already see that our y-axis only goes up to 11. So we're going to end up plotting somewhere up here. Okay, let's go. There's 1 and 4, 2 and 7, 3 and 10, and 4 and 13. Okay, draw a line through, and there we go. Now, because our gradients are not the same and they're not related at all, so it's not even like it's 3 and minus 3, they're not related at all. Even though it goes through the y-intercept, you can see quite clearly those do not meet perpendicularly. Okay, the one is not perpendicular to the other one. So these graphs are unrelated. They have the same y-intercept, but they have got completely different gradients. Okay, let's go on. Let's have a look at the third one. Y is equal to minus x minus 5, or y is equal to x minus 5. I would say from that, they're perpendicular, they have totally opposite gradients and the same y-intercept. Okay, so it's not just that the gradients, the one is negative and the one is positive. The one is negative 1 and the other one is positive 1. So it's completely opposite. Right, so let's have our Cartesian plane. And we're going to draw our table where x is 1, 2, 3, and 4. We're then going to substitute in where x is 1, it'll be minus 1 minus 5 gives me minus 6. Where x is 2, it will be minus 2 minus 5 gives me minus 7. Where x is 3, it's minus 3 minus 5 gives me minus 8. And where x is 4 minus 5 gives me minus 9. Right, let's plot these points. Okay, we've got 1 and minus 6, 2 minus 7, 3 minus 8, 4 minus 9. Make sure that you draw your line long enough so that it goes through your y-intercept, which there we go, it goes through minus 5. Right, let's do the yellow graph. Okay, we've got again x is 1, 2, 3, 4, and we then substitute in where x is positive x. So 1 minus 5 is minus 4, 2 minus 5 is minus 3, 3 minus 5 is minus 2, and 4 minus 5 is minus 1. Let's plot these. There we go, there we go, and there we go. So we've got 1 minus 4, 2 minus 3, 3 minus 2, and 4 minus 1. Okay, the y-intercept again is at minus 5. Draw the line, it goes through the y-intercept. Can you see that these lines are perpendicular? How can we tell? Well, they go through the same y-intercept and their gradient is directly opposite. Okay, so the one is minus 1, the other one is plus 1. So when it goes through the same y-intercept and the gradient is the opposite, you can say that they are perpendicular. So here there would be a 90-degree angle formed. All right, going on, let's do number 4. Y is equal to 2x minus 2 and y is equal to minus 2x minus 1. Okay, here our gradients are opposite, but the y-intercepts are not the same. They are unlike. So these two graphs to me would be unrelated, but let's see. There we got our Cartesian plane and our blue graph. Okay, where y is x is 1, 2, 3, 4. Where x is 1, it would be 2 times 1 minus 2 gives me 0. There's the point. Where x is 2, it's 2 times 2 is 4 minus 2 gives me 2. There's the next point. Where x is 3, 3 times 2 is 6 minus 2 is 4. Next point. And where x is 4, 4 times 2 is 8 minus 2 is 6. Right. Join the lines. Make sure it goes through our y-intercept, which is minus 2. As you can see, it does there. So that is our line. Right. Let's look at the yellow graph. We've now got minus 2x, which is the opposite gradient. So that should tell us that we've got a negative gradient. And now our y-intercept is different. So we've got 1, 2, 3, 4 for x. We plug in the 1. 1 times minus 2 is minus 2. Minus 1 is minus 3. There we have it. We've got 2. We plug in the 2. 2 times minus 2 is minus 4. Minus 1 will give me minus 5. 3 times minus 2 is minus 6. Minus 1 gives me minus 7. And 4 times minus 2 is minus 8. Minus 1 gives me minus 9. Okay. Join the lines, make sure it goes through the y-intercept, and as you can see there it does, there's the minus 1, that you can tell is definitely not a right angle. So those graphs are not perpendicular, in fact they are unrelated. Okay. The only thing that's the same is that the number value in the gradient is the same, but the gradients are opposite. And because they cut the y-axis at a different point, they cannot be perpendicular. Right, and the last one. Well, our yellow line has already appeared, so we know what that's going to look like, but never mind, let's carry on. Okay, we've got different gradients, different y-intercepts, we can pretty much say that these graphs are unrelated. There is our Cartesian plane. There is our blue graph points, our blue ordered pairs, where x is 1, y would be minus 2, because 1 minus 3 is minus 2. Where x is 2, it would be minus 1. Let's fill those in so long. Where x is 3, it would be 0. That's the x-intercept. And where x is 4, sorry, y is 1. Okay, join those up. Make sure it goes through the right intercept. Your y-intercept is minus 3. There we can see it does cut minus 3. Okay, the yellow graph, 1, 2, 3, 4 for x. We plug that in. 3 minus 1 is minus 2 should be. That's right, yes. 6 minus 1 is minus 5. That point is right. 3 minus 9, sorry, minus 1 is minus 8. Let's just fix this. I fixed that graph for us. Sorry about that, or rather the table. Okay, so where x is 1, y will be 3 minus 1, which is 2. Where x is 2, that's 6 minus 1 is 5. Where x is 3, that's 9 minus 1 is 8. And where x is 4, that's 8, it's 12 minus 1 will give me 11. So let's plot those points. There you can see 1 and 2, 2 and 5, 3 and 8, and 4 and 11. And we're going to join those, and you can see that it goes through the y-intercept at minus 1. But as you can see, the graphs are completely unrelated. How can we tell? We can tell because the y-intercepts are different and the gradients are different. Got myself a bit confused there. Okay, thank you, grade 9s. I hope you can see how we can relate graphs, and just by looking at the formula we can actually say whether they are related at all. So one thing we need to look at is, are the y-intercepts the same? If the y-intercepts are the same, are the gradients the same, or are they opposite? If they are the same, obviously the whole graph will be the same. If the gradients are directly opposite, it means that they're probably going to be perpendicular lines as long as the y-intercept is the same. Okay, where the gradient is the same and the y-intercept is different, they're probably going to be parallel lines. But where both are different, they are going to be totally unrelated. All right, everybody happy? Okay, please don't forget that if you've got any queries, you send your queries through to grade9@worksheetcloud.com and somebody will get back to you with an answer. And also don't forget to do the activity that is attached to this lesson. Right. Thank you so much for watching, grade 9s, and that was the end of our series on functions and relations. And the next time we'll be going on to something just as exciting. Thank you so much for watching today, and I hope you keep well till next time. Bye-bye for now.